We're going to go over the formula of a hydrate compound pre-lab. In this lab we're going to find the formula of a compound. Don't forget to find the formula. We have to change percent to grams, grams to moles, and then we divide by the smallest. So in order to do that, the first thing we have to do is to find our percents. From our data, we see that we know the percent of the sodium, carbon, oxygen, hydrogen, but we do not know our percent water. So the first part of our lab is to find the percent water. We're going to take a crystal. We're going to put it into a crucible with a lid, and it's going to weigh 30 grams. If we heat that, we know we're going to drive the water off, and so it's going to lose weight because of the water being driven off. All we got to do now is to find the percent water that was lost. To do that, we have to find the mass of the crystal that was placed in the crucible. So if we play our cross-out game, we'll take our crucible, lid, and that will give us the mass of our crystal. So we're going to take 30 minus 20, and that will be 10 grams. It's going to be the mass of the compound. The mass of the residue now. So let's play our cross-out game again. We're going to take our lid, crucible, and that's going to leave us with our contents. So if we take the 26.2 minus the 20, 26.2 minus the 20 is going to give us our 6.2 grams of our residue. So the mass of the water lost. Well, if this was our crystal, this is our residue, we must have lost 3.8 grams. So now we need to find the percent water. Percent is part over whole. 3.8 was the part that we lost. The whole was 10 times 100, and the 3.8 divided by 10 is going to give us our 38% water. So if we come down here, now put it into our table, 38% water. So now we're ready to do our percent to grams, grams to moles divided by the smallest. So here are our percents. Our grams are going to be, so our 16.9% is going to be 16.9 grams. This is going to be 17.7 grams, 58.8 grams, 6.67 grams, and our 38 grams of water. So we change percent to grams, and now we're ready to grams to moles. To do that, we take our grams, place that to the bottom, grams to the bottom, grams to the bottom, grams to the bottom, grams to the bottom. Now we get our masses from the periodic table. We know sodium weighs 22.99. That's 22.98. We know that carbon weighs 12. We know oxygen weighs 15.99. We know that hydrogen weighs 1. And we know that water weighs 18. So all we're doing, and the top has to be our mole at the top. So nothing new yet. So now we're ready to just calculate our moles. So put that in the calculator. I already have them worked out, so I can do it real quick for you. We have 0.735 moles of my sodium, 1.47 moles of the carbon, 3.68 moles for the oxygen, 6.67 moles for the hydrogen, and the water turns out to be 2.11 moles. We change percent to grams, grams to moles, now we divide by the smallest. Looking at this, our smallest is the 0.735. So I'm going to take all these, divide them by 0.735. 1.47 divided by 0.7345. 1.47 divided by 0.735. Sorry about that, 3.68. 6.67 divided by 0.735. And again, 6.67 divided by 0.735. Alright, So when we do the math, obviously this is going to be 1. This turns out to be 2. This will turn out to be 3. This would turn out to be, oh, this turned out to be 5. And 9. And this should be 3. So we have in our compound, forgetting the water, we've got this as our ratio of sodium, our carbon, our oxygen, and our hydrogen. Now in our compound, we have this much water. So we have 3 H2Os. So our 3 H2Os, 3 times 2 is going to take our 6 H's, and it's going to take 3 oxygens. So of these hydrogens, there are 9 of them, 6 of them is from the water. So let's subtract off the 6, and that leaves me 3 hydrogens for my compound. Of the oxygens, 3 of them are due to the water. So subtract off the 3, that leaves me 2 oxygens for my compound. So now I'm ready to write the formula of my compound. So from my compound, I see that sodium is going to be a 1, carbon would be a 2, oxygen is a 2, hydrogen is going to be a 3, and our dot 3 waters. And so that would be the formula of our compound.